All right, guys, let's go on this practice test here. Number 1. Remember, you need to simplify everything that you can before you do the limit if necessary. Like, for example, if I put that 2 in there, it just won't work. So I'm going to say the limit as x approaches 2. Let's factor this numerator, make it x plus 3, x minus 2 over x minus 2. Obviously, the x minus 2s are going to cancel. So that leaves me with the limit as x approaches 2 of just x plus 3. Now to have it down to a polynomial, I can just substitute the 2 in. 2 plus 3, the limit is 5. Let's go to number 2. Number 2's got a cube. Got to remember how to cube things here. Because again, if I were to plug 0, if I can't substitute right now and make the denominator 0. So take your limit. Let's work out the top. So I'm going to cube the 2. I'm going to get 3 times 2 squared times h plus 3 times 2 times h squared plus h cubed, and of course the minus 8 at the end, all that over h. Let's keep simplifying the top a little bit. The 8's are going to cancel for sure. I'm going to have a 12h and a 6h squared and an h cubed, and all that's over h. So I'm going to cancel out all my h's. So I'm going to limit as h approaches 0 of 12 plus 6h plus h squared. And if you now you can plug in the 0, and you will get 12 plus 0 plus 0, which is 12. Number 3, same deal here. Can't substitute yet because the 7 will make the denominator 0. So I'm going to say the limit of, well, let's go ahead and do it up here. Let's multiply the conjugate. We did that a few times this week. So I'm going to do x plus 2. A lot of times that helped. Plus 3, the square root of x plus 2 plus 3. When I work out my numerator, that's f, which should be first, x plus 2, last, minus 9. My denominator is going to be x minus 7 times the conjugate, which is x plus 2 plus 3. My numerator, if I simplify that numerator, it's going to be x minus 7, which is very convenient because I also have that in my denominator. And this is kind of how it worked out for us all week. Really worked out for us pretty nice. Not sure what happened right there. The x minus 7s are going to cancel. So my final limit here is going to be 1 over the square root of x plus 2 plus 3. Now you can plug in the 7. You get 1 over the square root of 9 plus 3, which is 1/6. And there you have it. Number 4, absolute value with a limit. Remember, absolute value, we talked about a lot this week. We can do the limit of x approaches -4. We need to do it from the left-hand side. And from the left-hand side, the absolute value of a negative number is the opposite of itself. So it's going to be the opposite of x plus 4. And if you do the limit approaching 4 from the right-hand, -4 from the right-hand side, the limit is itself. It's just x plus 4. So now I can go ahead and plug the -4 in. If I plug -4 in right there, I get 0. If I plug -4 right there and I get 0. And because I got 0 both places, the limit is 0. If you get different numbers on those two limits, it does not exist. Number 5, that may happen here. Let's see what happens. Same deal with the absolute value. So I'm going to say the limit as x approaches 0 from the negative side. That's going to be the opposite of the absolute value over x minus 2. Also going to do the limit as x approaches 0 from the positive side. That's going to be itself over x minus 2. So what that gives me here, if I cancel here, it gives me the limit as x approaches 0 from the negative side is -1, which is -1, by the way, because it's a constant. And over here, it would cancel, and I would get limit as x approaches 0 from the positive side is just 1, which is not the same as -1. So that one, DNE, it does not exist. Let's see what we can find for 6, which must be on the next page. Number 6, find the limit of a piecewise. All right, find the limit of a piecewise, and it's going approaching 2. I'm going to do the same thing. I'm going to go limit as x approaches 2 from the left-hand side, which is less than 2, by the way. So that means I'm using this one, which is x minus 1. And the second part, I will have to do limit as x approaches 2 from the right-hand side, which is this one, the greater than side, which would be the x squared minus 4x plus 6. So now it just comes down to substitution. So I'm going to plug 2 in there. 2 minus 1 is 1. I get 1 on that side. Over here, I would get 2 squared minus 4 times 2 plus 6. That would actually be 2. And because those are not the same, that limit does not exist. It can exist, and sometimes will exist, but this time it did not. Let's go to 7. All right, don't forget the what we did. We figured out we could do this yesterday, or in class, as we said. You could always say the limit as h approaches 0 of f of a plus h minus f of a all over h. You just work out that limit, and you should be good to go. So a plus h. First of all, a is the x-coordinate, which is the 2. So I'm going to say the limit as h approaches 0 of, I like to rearrange. I'm going to do h plus 2, or 2 plus h, doesn't really matter. That's supposed to be f of h plus 2, or 2 plus h, minus f of a, which in this case is 2, f of 2, all that over h. Just going to start working stuff out here. So I got limit as h approaches 0. If I plug in h plus 2 in my fraction here, I would get h plus 2 over h plus 2 plus 1, which is like h plus 3. This is a numerator, by the way. Minus, if I plug in 2, I'm going to get 2/3. All that's over h. Now, to get rid of a fraction in a fraction, I'm going to multiply the top and bottom by the LCD, which is 3 times h plus 3. Do the numerator and the denominator by that. And when I do that, my first term here, the h plus 3's would cancel, so we get 3 times h plus 2. My second term, the 3's would cancel, I would get 2 times h plus 3. In my denominator, I'm going to have 3h plus 3. So a lot of stuff. All right, so keep on working. I'm going to simplify my numerator. I'm going to do a lot of stuff here at once. I'm going to distribute right here. That'll be 3h plus 6. This is going to be negative 2h minus 6. I'll write that out. It'd be 3h plus 6 minus 2h minus 6. The 6's are going to cancel. That just leaves me h over 3h, h plus 3. All right, keep on going. The h's cancel. So my last limit here, limit as h approaches 0 is going to be 1 over 3 times h plus 3. And if you plug in a 0 in there, you're going to get 1/9. Okay, so that's the slope. This one said find the equation. So I'm going to take that point. I'm going to say y minus 2 equals 1/9 x minus 2. And just distribute the 1/9, which is going to be 1/9 x. I'm at the bottom of my screen. I'm going to move it up. 1/9 x minus 2/9, and then just move the 2 over. So get y equals 1/9 x. 2 is really 18/9 minus 2/9 would be 16/9. And there's your equation right there of the tangent line. No big deal. Not much work there. All right, I'm going to erase that one because I wrote all over number 8. Let's see if it'll go away. There we go. One more. All right, number 8. Number 8 says, again, find the equation of the tangent line. So I'm going to do the same thing, that equation at that point. So starting the same way. I'm sorry, I just can't write much smaller on here. That's what it is. So I'm going to say the limit as h approaches 0 of f of negative 1 plus h, or you can put h minus 1. I think that's what I did last time, which is I should probably do the same thing again. Minus f of a, which is negative 1, all over h. That's where I'm going. So I'm going to plug that in. If I plug in negative 1 plus h, I would get this. I would get negative 1 plus h plus negative 1 plus h squared. And if I just plug in the negative 1, I get negative 1 plus negative 1 squared. That's going to be 0, it looks like, all over h. Okay, so I'm going to simplify that a little bit. So I get the limit as h approaches 0 of negative 1 plus h. Now I'm going square, multiply double square here. Square the 1, multiply together double, square the h, all over h. The ones are going to cancel. They're out of here. That gives me h squared minus 1h over h. Now my h's are going to cancel. And as h goes to 0, h goes into h squared 1h time, and h goes into h 1 time. So that's what I have left. So I'm going to substitute 0 in there, and I get negative 1. That's my slope. There's my point. So I'm going to go y minus 0 equals the slope times x plus 1. All right. All I have to do this time is distribute the -1 because the y is already by itself. So it gives me negative x minus 1. And there you go. That's the slope of the tangent line at that curve. All right, now 2 of those tomorrow, so make sure you're good with those. All right, let's go to number 9 here. I got to erase this. Okay. Number 9. If $8,000 is invested in an account for which interest compounded continuously, that's the key word, find the amount of the investment at the end of 12 years. That's the formula we were doing last week. That's P of T equals P sub 0 e to the KT power. Or we've done it this way too. I guess we've done this. We've done A equals P e to the RT. I think that's the way we've gone with it most of the time. So at the end of 12 years, the P is 8,000. I'm investing 8,000. E, my exponent is going to be 0.07, which is the rate, times the time, which is 12. I'm just going to punch that right smack into my calculator. Just did that, and I got this number right here. I got 18,530 and 94 cents. Sorry about that. Come on now. Come on. Okay, that's 94 cents. I was trying to erase it, couldn't do it.
Hi.
Hey, give me about 3 more minutes. Y'all are soaked.
I just wanted to say hi. See how
How's your day
been.
going?
It's been
awful.
It's
Pretty
not
bad.
what I thought it would be.
Better or worse? Okay.
Well, I thought they were gonna talk about careers,
Yeah, and they're
but
not.
they just we talked about essays for
They
an
just told us
hour.
the same thing like 6 times.
I got you.
But I know it's their job, so
It is. Hang in there. He's got a couple more hours.
yeah,
You got it?
got it.
You got it.
How's your day been?
Good, but different. I mean, y'all aren't here, right? So it's,
Yeah.
everybody's just, classes are real small.
Is that why we didn't have a video?
Yeah. You'll have one tonight, though.
Okay, sounds good.
Have fun. Hang in there.
Bye.
Bye.
Yeah. Okay, make it nice and pretty like that. Now, the asymptote is usually the y-axis, but because I have this -2 in the parentheses, my asymptote is actually going to go right 2. So the asymptote is going to go right through 2 right there. So that's the asymptote. Remember, our first point on a log is always 1 to the right. And that works because anything to the 0 power is 1. Now, to get our second point, what I need to do is I need to make that parentheses be the same value as the base. Well, the base is 3. So what I'm going to do is I'm going to put 5 in for my x. And if I put 5 in for x, that gives me this. It gives me log 3, which is 1, by the way. So that means my second point, I plugged in 5, and I got 1. So I'm going to go to 5, 1. 1, 2, 3, 4, 5, 1, right there. And then I can draw my graph going just like this. So there's the graph. Okay, then it says tell your domain. Your domain is how far left and right it's going. It's going from 2 to forever. Now, it doesn't touch the 2, so make sure you have that in a parentheses, not a bracket. The range is going up and down forever. All log graph ranges are the same. The asymptote is a vertical line, so it's x equals, and it's going through 2, so it's x equals 2. All right, that's all you need. Hope that makes some sense. Doesn't seem too bad to me. Maybe it is, maybe it's not. I hope it's not. Use this as much as you need to. I'll be there school early or during the day if you need to come see me for questions. All right, come see me if you need to. Do great. See you.